You ever wonder how those incredibly powerful AIs you hear about can actually fit inside your smartphone? Well, the secret is this really cool process called knowledge distillation. So let's dive into how we teach these massive AI models to think small. But first, let's start with a question. We hear about these unbelievably smart AI models, right? The ones that can do all these amazing things. So why can't we just, run them on our phones or our laptops? Why are they basically trapped inside these giant, faraway data centers?
And this really hits the nail on the head. On one hand, you've got the huge AI models. They are geniuses for sure, but they're also slow and super expensive to run. Then, on the other hand, you have your smartphone. It's compact, it's efficient, but let's be honest, it has pretty limited power. It really feels like you can't get the best of both worlds.
So this whole conflict, this is what brings us to our first big topic, AI's big model problem. And it's not really a problem with the AI itself, it's a huge challenge for actually using it. Okay, so here's the bottom line. The models that have the most knowledge, the ones that are absolute rock stars at things like recognizing photos or understanding what you're saying, they're just, well, they're too big. They are way too power hungry for our everyday gadgets. Trying to get them out into the world, onto your device, is a massive technical headache.
So, how in the world do we fix this? Well, the solution is actually beautiful, and it's really elegant. You can understand the whole thing with a simple metaphor: the teacher and the student.
And here it is, the official definition. Knowledge distillation is all about taking one of those big, clunky, but super smart models, let's call that one the teacher, and finding a way to transfer all of its wisdom into a much smaller, nimbler student model. And the goal here is pretty simple, right? You want to end up with a compact, super efficient student model that can perform almost as well as its giant teacher. So you get all the brainpower of the big model, but in a package that can actually run on your phone. But how does this knowledge transfer actually work? I mean, how does the student learn the teacher's secrets? Because it's not just about getting the right answers. It's way cooler than that. See, in typical AI training, the model learns from what we call hard answers or hard labels. It gets shown a picture and it's told, this is a cat, period. It's a very black and white, right or wrong world, which doesn't really leave much room for any nuance. But this is where the magic really happens. A teacher model doesn't just spit out the hard answer. As you can see here, it gives probabilities. It says something like, okay, I'm about 90% sure this is a cat, but there's maybe an 8% chance it could be a dog and a 2% chance it's something else. It's actually showing its work. These nuanced little outputs are called soft labels, and they are the absolute key to this whole thing. By learning from these probabilities, the student model doesn't just learn the final answer, it learns the teacher's thought process. It's learning why the teacher thinks an image is more like a dog than, say, a bicycle. This is that dark knowledge you might hear about, all the subtle stuff that isn't obvious from just the correct answer. And get this, scientists even have a knob they can turn to control this process. They use a parameter called temperature, and it basically acts like a detail dial. You turn it up and you encourage the teacher model to reveal even more subtle details in its probabilities. It's like giving the student a richer, more detailed lesson. Okay, now it is really, really important to make a distinction here. This whole teaching process is fundamentally different from just shrinking a model that already exists. They are not the same thing. And this table just lays it out perfectly. With knowledge distillation, the goal is to transfer knowledge. You do that by training a brand new model from scratch, just like a professor teaching a student. Model compression, though, its goal is simply to reduce the size of a model by cutting parts out of an existing one. That's more like an editor taking a huge book and just turning it into a short summary. See? Totally different goals, totally different methods. And this idea didn't just pop up out of nowhere. As you can see on this timeline, it's actually built on decades of research. You can trace the evolution from these early ideas about trimming down networks back in the 80s to the first teacher-student concepts in the 90s, all leading up to 2015, when the AI pioneer Geoffrey Hinton and his team really defined the process we now call knowledge distillation. So why does any of this techie stuff matter to you? Well, because it's what puts all this distilled AI right into your pocket. Seriously, this isn't just theory, it is everywhere. Think about the real-time object detection your phone's camera does, or the acoustic models that let voice assistants like Siri or Alexa understand you instantly. Even those on-device translation apps that work without any internet. A lot of these powerful features rely on knowledge distillation to run efficiently right there on your device. So,
At the end of the day, that's what this is all about. Knowledge distillation is the bridge. It connects the incredible power of those massive data center AIs with the convenience and the privacy of our own personal devices. It's what makes smart technology something we can all actually use.
Which leaves us with a final, kind of mind-bending thought. We figured out this amazingly effective way to distill complex computational knowledge into a form that's way more accessible. So it makes you wonder, if we could apply this same teacher-student idea to our own vast ocean of human knowledge, what really complex subject would you want to distill first?